reflection of light. Okay. So before reflection, let's start with the refraction. What does a refraction mean? Refraction means like when the light comes back to the same medium after it hits onto a bright surface, it is going to be refracted. We call this refraction of the light. Okay. For example, when you put a pen inside of the water, you're going to see that the pen is going to be broken. So this is because there are two mediums over there, and there is a like density difference between this medium, and you're going to see the pen like that inside of water. When you send light, for example, inside of a prism, you are going to see that the light is going to disperse its components, 7 different colors. So we call this process refraction. So there are two types of reflections. The first one is regular, the second one is diffuse reflection. So the regular reflection, you send, as you see over here, you send light rays over here in a smooth surface, and the light ray is going to be reflected like this. And when you send the light rays to a rough surface, the light rays are going to like reflect it differently because of the surface. So we call this type of reflection diffuse reflection. So we are going to consider that regular reflection under the title of the reflection. The first one, if the ray coming towards the surface without any angle with normal of the surface, like this, for example, if it comes to 90 degrees, we're going to call this normal. When you see this line divide a mirror into, or divide a surface into two parts, we are going to call that a normal. Okay. So that means the ray, what's going to happen to the ray, or incident ray? We are going to call the ray which is coming incident ray, and the reflected ray is going to be called reflected ray. Okay. So as you see, incident ray coming to the mirror at 90 degrees, it is 90 degrees, it's going to reflect over itself. So this is going to be reflected ray. So if the ray comes towards the surface with an angle like theta, with the normal of the surface, it is going to be reflected as it is like theta. It could be theta 1 and theta 2. Okay. So here, as you see, the incident ray is theta 1 and the reflected ray will be theta 2. Okay. So here, theta 1 and theta 2 must be equal because the surface is smooth, okay? When the surface is smooth, the reflection will happen in this at the same angle, okay? For example, here is 45 degrees. That means here is going to be also 45 degrees, okay? So then, let's continue. These are the two important rules of reflection, actually. The third one is both incident ray and reflected ray are in the same plane. What does same plane means? That means on the same surface, okay? When you send it, it is going to be on this plane, and when it's reflected, it's going to be again on the same surface over here, okay? So there is an example over here. Find the path of the ray after reflection from the reflected surface. For example, there are two surfaces over here, okay? It is 90 degrees. When you send a ray like this, what's going to happen? Let me just take the pen over here. So when you send it, again, let's say you send it with 45 degrees, the reflection will happen, and you're going to put a normal here, okay? The normal is going to be between the reflected and incident ray, and the ray is going to be reflected. If it's coming like 45 degrees, then the reflected ray will be reflected by 45 degrees. Again, it is going to come to this surface at 45 degrees. Again, you're going to put it normal over here, and then it is going to be reflected at 45 degrees. So the light ray is going to be reflected like this on these two surfaces, okay? The angle of incident and angle of reflected are going to be the same. The second one, let's say we have a surface like this, okay? And we are standing like 30 degrees. Again, we're going to put a normal over here. Here, since here is 60 degrees, here is going to be 60 degrees because, and if you don't know what is going to be the angle over here, look at here. When you put the normal over here, it's going to be 90 degrees, okay? So 90 degrees. You have 30 degrees here. So that means 60 degrees will left over here. So the second one, the reflected ray, the angle of the reflected, again, it's going to be 60 degrees. Why? Because angle of incident here is going to be equal to angle of reflected over here. And then when it goes to this surface, second surface over here, as you see from the triangles, like from the angle of internal angle of the triangle is 180 degrees, you can just find the angles necessary over here. Since here is going to be 30 degrees, again here is going to be 60 degrees, because you're going to put a normal over here, so it should be 90 degrees, and angle of incident equal to angle of reflected, so here is going to be again 90 degrees. Okay, so this is going to be the reflection of the second light ray. All right, so let's continue. Let's go to the plane mirrors. What does plane mirror mean actually? Plane mirror, the mirrors that you use at home. Okay, the mirror that you use like bathroom when you look at yourself. Those mirrors are called plane mirrors. So plane mirrors, what are the some characteristics of plane mirrors? It has a plane surface which is polished. It gives clear image. Okay, the mirror usually use manufactured from a thin glass plate, silver or coated with mercury. That's why you can see your reflection on the mirror. Okay, because it has a silver or coated with mercury. The plate, the behind the mirror. That's where you're going to see yourself on the mirror. So how does image formation happen in plane mirror? So in order to construct the image luminous point, at least like two rays of the beam from this point, they're going to be incident and intersected. So all rays intersected at one point are the rays from the object, the image form called as real image, okay? The real image is going to be formed in front of mirror, okay? And the virtual image is going to be formed behind mirror. When you, if you don't know which is real, which is virtual, you're going to see this. You're going to remember this. Real images form in front of mirror, and virtual image form behind mirror. Okay. So for example, here there is a plane mirror over here, and it's your eyes. You are looking at an object over here. Again, the normal is going to be over here, and when you send the ray over here, it's going to show like this. And the other one again. So you are going to draw the deer like virtual part, and the place where they meet, you are going to see the object. Okay, you're going to send two rays. One of them is like this. You're going to take the virtual image of the first ray and the second ray, and the place they merge, the object will be formed over there. Okay, so the distance from the object to the mirror and image to the mirror are going to be the same in the plane mirror. Okay, if it's 2 meters here, that means it's going to be 2 meters from here. Okay, behind mirror. All right, so for example, there's a candle over here. You want to see where a candle is going to be. You send a ray at the 90 degrees because you're looking here, and the ray is going to be reflected on itself. So this is going to be 1, and the second ray you send it and normal, it's going to be reflected like this. Now you're going to draw it, and then that is going to be where the image of candle going to be formed. Okay, you're going to send from the, okay, all right. So the image of the reflected ray is going to be, the image is going to be over here, as you see. Again, you're going to send 2 rays always to get an image. If you send just 1 ray, you're not going to be able to get the image of the object. There should be 2 images. So properties of what are the properties of the plane mirror? First of all, the distance between object and between the mirror image are going to be the same. They're going to be equal. Again, if it's 2 meters here, it's going to be 2 meters behind the mirror. So the object size and the image size are going to be equal. Remember yourself, when you look at yourself in the mirror, you are going to see your image as it is, like whatever you see, like whatever your height or whatever your body part is measured, it is going to be the same as image in the mirror. So the object and image are symmetrical. They do not superimpose. What does this mean? That means you are going to see the reflection as it is. Okay. But if you wear something like, let's say you wear a colored like t-shirt which has some leather on it, you're going to see that leather are going to be upside down. Okay, leather are going to change their direction. So this is due to symmetry. If the object moves with a speed of v, like if the object moves speed of v, then the image is going to be in opposite direction with negative v. Okay, so basically the velocity will be 2v, the total velocity of the image when you see it. The fifth one, image formed by two mirrors meeting at an angle. We need this. When there are two angles, if you want to find the number of the image, you're going to use this formula. N equal 360 degrees over alpha, the degrees that given to you, minus 1. For example, there is an, let's say you send a, like a ray which is inclined at 90 degrees. That means you're going to divide here 360 over 90. That is minus 1. It is going to be 3 images. So 3 images are going to be formed in two mirrors due to reflection. If you send the object, like let's say by 45 degrees, you send the ray by 45 degrees, you're going to say that 360 over 45 minus 1, which is going to be 7 images are going to be formed in two mirrors. Okay, so this is the formula. There are two surfaces like this. You send the rays 90 degrees here, for example, and you send the ray here. Okay, so this is, you're going to get the image like this. You can send like in different perspective to the mirrors. So 3 different image, you got it. Okay, because you send it at 90 degrees. So as you see, you got 3 different images. So I'm going to give you this question. You can do this question later on. Okay, with 360 degrees, with 60 degrees, with 180 degrees, with 30 degrees. Let me see, there is a question. Nope. Yeah, image is not going to be upside down. Why? Because of the property of the plane mirror. Okay, it's not going to be upside down. But when we learn about, like we are going to go learn about the concave and convex mirror, over there you're going to see that sometimes image is going to be upside down. But for plane mirror, it's going to be upright, always erect. We call it erect. So it's going to be always erect and behind mirror, and it's going to be virtual. Okay, it's not going to be real image, but virtual image behind mirror. All right. So these are the some, for example, let's say you send the ray at 60 degrees to the surface. That means how many images are going to be formed over here? So 360 over 60, it is going to be 6 minus 1, 5. So here you're going to have 5 images, okay? So you're going to have 5 images here. What about when you send with 360 degrees? What's going to happen? You're going to have -1 image. That is impossible. So you cannot get the -1. So that means you're not going to have any image formed when you send with these degrees. When you send with 180 degrees, you're going to have only one image. 360 over 180, which is going to be 2. 2 minus 1, it's going to be 1 image. So this is basically what it is, okay? So let's continue then. So area of side of plane mirror. So for example, if you want to find the area side of the plane mirror, you're going to send it here at the beginning and at the end of the plane mirror. Again, there should be normal, and where the image, like reflection ray, you're going to see the reflection ray over here. This is going to be the area of the side. Okay, the reflections between two reflection ray, there is going to be area of side. So so what about concave mirrors? Okay, let's start with the like concave mirror, and then we are gonna move to the convex mirrors. So concave mirrors, as you see, their surfaces are like this. They look like, think about a spoon. Let's say you have a spoon. Inside of the spoon is going to give you concave mirror, okay? The shape of the inside of the spoon. And outside of the spoon will give you the convex mirror, okay? If you don't, like, if you have difficulty to remember which one is concave, which one is convex mirror, think about a simple spoon. Inside gives you concave, outside gives you convex mirror. Okay, so a convex mirror looks like this. A concave mirror looks like this. It has a shiny surface. It has over here a center, and it has a focal point. We call this center of curvature. The radius of the curvature is from the pole. Here is called pole from the center. Okay, and here we are going to have a focal point. Focal point is half of the center. Okay, that means it's going to be half of the radius of curvature. Okay, here is focus. So focal length is going to be again half of the radius. What about convex mirror? As you see here, convex mirror, it is different. It looks like outside of the this part. You're going to check this part. Okay, so it is going to be it's going to look like a what do you call it, a outside of a what do you call, like spoon. Okay. So this time the center of curvature is going to be behind mirror. Okay. It's going to be behind mirror, and focal point is going to be behind mirror. Image is going to stand over here. When you see the image, is going to stand over here, and the object is going to stand over here. Sorry, and the image is going to be formed behind the mirror. Most of the time, they're going to come there. Again, the focal length is going to be half of the radius of curvature. Don't forget this. So what are the special rays? So let's say there are a few rays that you need to know in order to get the image in concave and convex mirrors. So first of all, when you send the ray parallel to the mirror, what's going to happen? When a ray comes to the parallel to the principal axis, this is the principal axis over here, it will be reflected over focus. Okay, it's going to be reflected like this. It is going to be reflected over focus. Okay, so and second one, when you send ray through the focus, what's gonna happen? Like this. Then, sorry guys, just a second. Then the ray is going to be reflected over, and it's going to be reflected parallel to the principal axis. It's going to be vice versa. Remember the first one, we send it parallel, it goes to it reflected over focal point. The second one, you send through the focal point, it is going to be reflected parallel to the principal axis. These two rays are very important because whenever you get image in concave and convex mirror, you are going to use this property of the ray. Okay. What about when you send the center? When you send over the center, again, it's going to be reflected over itself. Okay. So incident ray and parallel ray are going to be reflected over center. When you send through the center, it's going to be reflected over center. So if the ray comes to the mirror towards the pole, what's going to happen? Then it's going to be reflected from the mirror by the same angle. Okay. Let's say you send it here by 30 degrees. Okay. So it's going to be reflected from the mirror by the same angle. Like it's going to be reflected by 30 degrees like this. Okay. When you send the pole, this is the pole. The fifth one, if the ray comes to the mirror in any direction, like any direction means like could come like this, like this, like this. So what's gonna happen? It's going to be reflected from the mirror as passing through the virtual focus. What is virtual focus? That means the virtual focus is behind mirror. Okay, this is going to be virtual focus. So when you send the ray like this, it is going to be like passing through the virtual focus, and it's going to be reflected like this. Okay. So this is the virtual focus. Virtual focus and virtual center are located behind the concave mirror. Okay. What about convex mirror? Convex mirror, again, if the ray comes to the parallel to the mirror, again, the part of the convex mirror is here. Okay. The image, the object stands here. When you send the light ray, you're gonna send it here, not here. So this is the focal focus and center of curvature is behind mirror. They are located behind mirror. As you see over here, you see that this is a what do you call it? This is a convex mirror. When you send the light ray parallel, it is going to be reflected like this. As you see, it's going to be reflected like this, and you are going to see that the reflected ray is like coming from the focus. Okay. It is light coming from the focus. And the second one, when you send through the focal, again, it's going to be reflected parallel this time. You send the focal, focus point, and it is going to be reflected parallel to the principal axis. And the third one, when you send through the center, again, it's not going to go to the center, but the reflection of it is going to go to center, and then it's going to be reflected over itself. These are the three basic ones. What about the if you send towards the pole? Again, it's going to be reflected from the mirror as parallel principal axis, the same as the thing that we learned previously. If the ray comes to the mirror in any way, it's going to be reflected again from a virtual focus. It's going to like coming from here again or here like this, and it's going to be reflected like that. So to form an image, at least we need two rays. Don't forget this. With one image, with one ray, you cannot form an image. If you want a proper image, you have to send two rays. It could be parallel ray, and it could be ray from focus point, because these are the two rays that are like easy to send. Easy to send from the object. Okay. So let's go to the first of all. Let's go to the object at the infinity. When you put an object at the infinity, the image is going to be like on the focus point. Okay, it's going to be like a dot in the focus point. You can say that if you put it in infinity, it is going to be around here. Okay, so it can be between C and F. C and F. If the object is located at infinity, the image is going to be between C and F. Okay. So nature of the image, what is going to be? Generally for the concave mirror, it is going to be inverted, diminished, and real. What does inverted mean? Inverted means it is going to be upside down, okay? Inverted, upside down. This is upside down. Let me write here. Diminished means smaller than the object. This is upside down, okay? Diminished means like smaller. And real means it's going to be in front of mirror. It's going to be here, anywhere here, like between C and F, anywhere. So that is going to be our image form. And the second one, what if you put the object like, let's say here is 1F, here is 2F the distance, and here let's say it is 3F. When you put the distance behind C, like at 3F, where you are going to see the like image. So first of all, you're going to send a parallel ray, okay? Let's send a parallel ray. Parallel ray is going to be reflected over focus point, and then you're going to send over a focus point, and then the ray are going to be reflected parallel to principal axis. The place where they merge here, it is going to be the image, okay? As you see, image is upside down, okay? Inverted, we are going to call it. And as you see, what is the size of the image? It is smaller than the object, as you see, okay? And it's going to be between C and F. It is going to be real, inverted, smaller than the object, or diminished. When you see diminished, it means smaller. When you see inverted, it means upside down. When you see real, it is going to be in front of mirror where the light rays merge. Okay. What about when you put the image at the C? When you put the image at the C, remember the rays when you send from C, they reflected over C. So the same thing here is going to happen. There is just only one difference. The image is going to be inverted this time. Okay, image is going to be formed on the center, but it's going to be inverted. The size of the image and size of the object is going to be the same. The image is going to be real and inverted. The size is going to be the same. Okay. So don't forget it, okay? When you want to get an image, you are going to use two rays. Don't forget this. What if you put between C and F? Remember, when you put it here, the image formed between C and F. This time, when you put it here, the image is going to be behind C. It is going to be formed there. It's like vice versa. Okay? Again, you're going to send a parallel ray and ray from focus point. The place where they merge is going to be the where the image formed. So as you see over here, the image is going to be larger than the object. It is going to be inverted and real beyond C. Okay. So image at 1.5 is going to be the object at 1.5. The image of the object is going to be at 3F. You can convert like you can comprehend like this. Inverted, magnified means larger than, and real. Okay. What if the image at F? Now you can try it yourself actually, but let me just help you out. Okay. So send like this. Again, send here, and it's going to be here. As you see, there is no merging point for the light rays. What does this mean? That means the image is going to be at infinity. Okay, when you put at F, the image is going to be at infinity. All right. So there is only one place where the object is going to be virtual. When you put the object between F and focal pole, then the image is going to be formed behind mirror. Okay, it is going to be formed behind mirror. So what does this mean? That means like the object is going to be virtual, erect, and it is going to be magnified, larger than the object, the image. Okay, erect means it is straight up like up straight over here, as you see. It is going to be magnified, and virtual, it is going to form behind mirror. Okay, this is the only way you can get image virtual or magnified, not image virtual and erect for the concave mirror. When you put the object between focal point and the mirror. Okay, this is the only way you can get it. All right, so now let's go to the convex mirrors. This time again, we are going to send the, let's say we are looking for the object is at infinity, the image of the object. It's going to be behind mirror again. So what is the nature of the image? It's going to be erect, smaller, as you see, it's very small, and it's going to be virtual, okay? Since it's behind mirror. What about when you put close enough to the mirror? What's gonna happen? Again, you're gonna send the parallel ray to the center. It is going to be reflect over itself. So here, we are gonna get our image, okay? The place where light rays merge, that is going to be the image that we need to see. Again, you see it's erect, means straight up. It is diminished, as you see, smaller than the object, and it's virtual behind mirror. Okay. So what are the some uses of curved mirrors? Again, you use like curved mirror, a shaving mirror, or makeup mirrors, especially for girls. You guys using for makeup mirrors, but we don't care actually about the shaving mirror. We just need a mirror to shave. So second of all, you use as a reflector over here. You see, this is a flashlight, and this is a reflector that you use as a reflector. The concave mirrors. The third one, like for telescope, for reflecting telescope, we use concave mirrors. The fourth one, for rare wave driving mirror, this mirror over here, we use convex mirror. This time we use convex mirror. Why? Because it shows us like a range, a large area. If you use plane mirror or concave mirror, you're going to have a small area to see. Okay, that's why it is better to use convex mirror for your rear view driving mirror. All right. So surveillance mirror, you can see this mirror when you go to the shopping center or when you go like if you are turning around a corner, and generally they put this mirror in order to show what's happening the other side of the like maybe shopping mall or like the market, or it could be like the road, what is coming from the road. Okay, so we use it as surveillance mirrors. So okay, let's just so when let's talk about the ladders. What does ladder means? Like it's giving you like h size of the object, h over its size of image. Di means like distance of the image to the mirror. R means radius of the curvature. Do means like distance of the object to the mirror. Okay, these are the some parts of the mirror. So except the region like positive and negativity, we are going to talk about it. Actually, let's pass this part. We don't need that. So to find the, let's see, let me just go to the formula that you need to know actually. So to find the like the side of the image, we are going to use this formula. Okay, 1 over f equal to 1 over distance of the object to the mirror plus 1 over distance of the image to the mirror. We are going to find the distance of the focal point. Or like if you don't know focal point, how much is the from the mirror, you are going to use this formula to find it. 1 over distance of the object plus 1 over distance of the image to find the 1 over focal point. We call this mirror equation. Okay. So there is an example. When the object is at the focus, where is the image? It's formed by a concave mirror. Again, send a parallel ray, send an image like this. As you see, the image is going to be formed at the infinity. Okay, 1 over f or 1 over d over plus 1 over like di. When you did this, you're going to get infinite here. As you see, infinite. Okay. What about this? Again, you can use the same formula. When you do this, this part is going to be positive if the image, the object part, and this part is going to be negative behind the mirror. Okay. So this of the object is going to be considered as positive. This of the object image is going to be considered as negative because it's formed behind the mirror. It is virtual image. That's why. So to find a magnification, we are going to use this magnification of the object, the distance of the image to the mirror over the distance of the object to the mirror. We call this again magnification formula. Okay. If the image formed behind the mirror, the equation will turn into 1 over do minus 1 over di. So let's Let me see how many. Just a second.